Very good morning. So in morning in this lecture number 32 we started this example on design of eccentric project column for uniaxial bending. Uh, actually, the strength of the column in uniaxial bending is nothing but it is n upon nd plus my upon mdy plus mz upon mpz should be less than or equal to 1. Then our design will be, we will say that okay. This is for the biaxial bending. This is for the biaxial bending. Okay, axially rolled column and biaxial bending. So this term is for axial load. This is about the bending about the minor axis and major axis. But in our example, this the bending, because eccentricity is only one direction. So major axis, the mz is the major axis. So only these two terms will be there. Our equation will come as a n upon nd plus mz upon mdz should be less than or equal to 1. If this equation satisfies that in strength, we will say that our design is okay. So we started this example. The load is given 750 kilonewton. The eccentricity only one direction to 70 mm. It is given, and this is the your ISA 450. The section is already there. We don't need to find out. So if section is given, you have to write the properties of the section and what is given you have to write down, and then we start solving the example. If section is not given, so you have to assume FCD. Assume FCD. And area required you have to find out for the section. That is 2 times of n upon CD assume. Okay. So 2 times of this load. If there is bending, then you have to find out from that area. And based on this area, you have to select the section, and then the other calculation is other steps are same. Other steps are same. Okay. So step 1 we have write down all the properties of the section given load, and then step number 2 we are finding out the forces and calculation of the moment. For major axis, we have calculated the moment is 202.5 Newton meter. Then section classification. Why we are doing the section classification? If plastic or complex section is there, then your A is equal to AD. Okay. And then we are find out the design strength in compression due to axial load. ND is equal to AG Fy on gamma m0, AG below. Fy we know gamma m0 we can take from table number 5 of gamma m, so we can take from table number 5 of IS 800 2007. Okay, that also we have taken, and then we know the effective length. It is directly given 3 meter, it means that 3000 mm. Then find out the lambda, that is slenderness ratio. The slenderness ratio is nothing but KL upon R minimum. L is the unsupported length of column, K means the factor, and this is nothing but LE. So LE is equal to KL, and this is already given 3000 mm. Then LE upon R minimum will give the slenderness ratio. We find out. Then we find out the critical stress in the section FCRB by using the table 14 of our ISO. The HF by TF ratio you can find out. This is the HF by TF ratio. Okay. and lambda we know based on HF by TF ratio, our HF by TF ratio is 31.84. We have calculated this, okay, and for 30 in I score for 30 and for 35 the value is given. Similarly for lambda 50 and 60 the value is given. For 57.91 the value is not given. For 31.84 the value is not here. Hence first we will find out the values of FCRB for 31.84, for lambda 50 and for lambda 60. Okay, this already we have calculated here. First value, okay, and the second value, okay, 655.4. Now we have to find out this will show in the red rectangular. This we have to find out, and that is the value of final FCR. Okay, now we know, again you have to do the interpolation. We know the for 50, I will write down separately. Now for 50, and our value is 30.84. We know the values, okay, and for 60 also we have calculated. For 60 we have calculated 655.43, 655.45, sorry, and for 50 we have calculated 921.54, 921.54. Now for 57.91 we have to find out the FCRB value, and that will be our final value. So this value we have to find out. If I will interpolate this, the interpolation will be like that. I will doubt on the interpolation. So I am finding for this value. If I will relate with this, so this value is minimum and this is maximum. This is minimum and this is maximum. So I will relate with the 50. So I will write down 921.54 minus, okay, I will relate it with the 50, so it will be 57.91 minus 50, because this value is of 50, okay. So this is the greater value, that's why we have minus sign, and then the difference between the extreme value is 60 minus 50, and then difference between the extreme value of this. Okay, so extreme value is 921.54 minus 655.45. So this is the final interpolation you can do. This is the final interpolation you can do. So this interpolation, you saw this value 921.54 minus this is 7.91. This is difference between these two is 10, and difference between this is nothing but is, to find out 921.54 minus 655.45 is coming to 266.09. Okay, if I will solve this, then the value of this 921.54 minus this 7.91 into 266.09 divided by 10, so it is 210.48 equal minus this 921.54 minus, so the answer is coming, the FCRB 711 Newton per meter square MPa. So this value from the I score we have taken the all HF by TF value 30 and 35. The value we have taken from here for 50 and 60. Okay, then we have done the interpolation between the 31.84 31 point is 84, and we get this value, this two value. Okay, this two value will get, and from this two value we have interpolate and we get the final value. This final value is nothing but 711. This final value I will write down 711. So how many interpolation we have done? Around first interpolation about this is first, second interpolation about this, second, and the third interpolation to find out our final values. This is the third interpolation. Okay. So three times you have to do the interpolation to find out the FCRB. Now we know the FCRB. Now we know the FCRB, but we know that our FCRB, we know that FCRB. Now we have to find out the FBD. Actually, we have to find out the, what we have to find out? We have to find out the FBD. Because MDZ is equal to beta B ZP into FBD. If you see in the IS code, the design strength in the bending beam column is nothing but MD, and MD is equal to beta B ZP FBD. If you see the clause number for laterally unsupported beam is beam, but if we are designing beam column, the MD is nothing but, you can see beta B ZP into FBD. Okay, so we know the value of FCRB now. So from this empirical equation, you have to find out the XLT Fy upon gamma m0 is the FBD. So you can find out phi LT, and this value of phi LT you can put into XLT, and you already find out FCRB, lambda LT is under root of Fy upon FCRB. So you know the lambda LT, you can find out phi LT. You know the phi LT, you can find out the XLT. And if you find out the XLT value, the XLT Fy upon gamma m0 is nothing but your FBD. Okay, this is the procedure if you are going for the empirical. But if you are going for the table, so IS code is given a table 13A and 13B. Based on this alpha LT value, because in our case this is the rolled steel section. So in rolled steel section, you can see here on page number 54, the alpha LT is 0.21. So in our case, if I will write down this step number, which is step number 7, this is step number, I think so 6 is there. I will write down step number 7. So this is step number 7. Step number 7. In our lecture, this is 13. Lecture you are studying, extra lecture you are taken, extra class. Okay, so this MDZ we have to find, because we know the N 750 kilonewton, we know the ND, that is 2525 kilonewton, we know the MZ, you have calculated, that is 202.5 kilonewton meter. Now we know we have to find out MDZ. This we don't know. So for this we have calculated FCRB. Now we have to calculate FBD. This we have to calculate. And this, because we know the section is plastic. We know the section is plastic. Section is plastic. From step number कौन सी स्टेप में हम लोगों ने मालूम किया था? स्टेप नंबर आई थिंक सो 3. Here step number 3, you find out section classification, and we find out our section is plastic section, class 1 plastic. So that's why if the plastic section is there, then the beta B value will be 1. Step number 3, section is plastic. Hence beta B value is equal to 1. Now, in this, we know the beta B value. We know the ZP from the IS code of the section. ZP, you know that in IS code at the last it is given. Come here. So ZP, that is section modulus, plastic section modulus for the ISHB 450. It is given already. So ISHB 450 will come here. You can see here the plastic section modulus, uh, section properties. Section properties. Plastic section modulus. Where is the plastic section modulus? I section, ISHB, ISMB, ISAB, LB, WB, ISHB. So here you can see where I am. Sorry. From here. So here ISHB 450 के लिए ISHB 450 you can see ISHB 450 about 87.2. So here plastic section modulus 1995 is already plastic section modulus ZP and centimeter cube is given, and already we have written there also. Okay, so ZP also we know. ZP we know from the properties of section. In step number 1 we have written this ZPZ, you can say 1955.03 10 to 3 ln cube. ZPZ already we know. ZP is already 1955.03 10 to 3 ln cube. Now what we don't know is FBD we don't know. So FBD you can find out from the empirical equation as I have explained, or you can find out from the table. Table 14, we go for table number is 14, 13, 13A or 13B. So in our case, since this alpha LT value is 0.21, because this is the lower distance section. So in our case, the alpha LT is nothing but 0.21 for rolled steel section. For rolled steel section, okay, from page number 54 of IS 800 2007. Okay, now we know the alpha LT value, and what more is required to find out this value. So alpha LT 0.21, okay. We need FCRB already we have found out. FCRB we already find out. It is nothing but 711. Okay, FCRB already we have found out is 711. FCRB already we have found out that is 711. So you can see this FCRB is 711. So FCRB is 711. You have calculated here. Okay, 711. Now you have to find out FBD. So here FCRB is 711. 700 के लिए वैल्यू दी है और 800 के लिए दिया है, लेकिन 711 के लिए दी है. तो अगेन वी हैव टू डू द इंटरपोलेशन, एंड FY we are taking at 250 or FY is 250. I will write down FY for FBD for FY 250, FCRB 711, and alpha LT 0.21 you can find. Now for 700 and for 800 the value is given. For this we have to find out the value. This we have to find out the value. So for 700 the value is for 250 it is 700. If you come 700 it is 202.3 and 800 206.8. So the value is given for 700 202.3 and for 800 206.8. This value is given. So FBD you have to find out. This FBD for 700 is given, for 800 is given, and this you have to find out. Okay. So again, by doing the interpolation, you can find out. I will take this value. This value is less, so I will interpolate is equal to 202.3. Now this is increasing, so here positive sign because 700 to 800 if you are going the value is increasing, not decreasing. Okay, so increasing value is there, so therefore here plus because it is larger. Okay, now I will write out 711 minus 700 because I have taken this value. That's why here the relation between the 700 and 711 divided by the extreme value. Extreme value is 800 minus 700 and the extreme this value which is 206.8 minus 202.3. Now if I will solve, this is the FBD what we require. So if you find out this, so this 700 and this is 11, this is 100, so 202.3 plus 11 divided by 100 into difference of this 206.8 minus 202.3, it is nothing but 4.5. You solve this by BD will be 202.3 plus this value, and this is nothing but 202.795 Newton per mm square is your FBD, that is design bending stress. So FBD is nothing but design bending stress. It's nothing but FBD. You find out. So it is FBD is not a design bending compressive stress. Design bending compressive stress is nothing but 202.795 Newton per mm square. Now we know that our MD is beta B into ZP into FBD. Now we know the FBD also, we know the ZP also, we know the beta B. Since plastic section beta B is equal to 1, is this plastic section. Okay, so that's why beta B is equal to 1. That's why beta B is equal to 1. Okay, so if you write on this all the value, so I will write down beta B is equal to 1, ZP 1955.03 equals to 3. When we convert centimeter cube into mm cube, we have to multiply by that equals to 3, and FBD is 202.795. If you multiply this, you will get the MDZ value. MDZ value equal to 1955.03 10 raised to power 3 into 202 this. We get the MZ is equal to 396.47 into 10 raised to 6 Newton mm, or if you write in kilonewton meter, it is 396.47 kilonewton meter. Now we will go for the step number 9, step number 8. We will find out the interaction equation. Here, here for uniaxial bending, only major axis, bending about major axis only. Therefore, my term will be 0. My will be 0. Therefore, n upon nd plus mz upon mdz will be less than or equal to 1. So n upon, you see the n value is the given load 750 kilonewton divided by nd is 2525.91, I think so, 2525.91 kilonewton plus mz is, you find out 202.5 kilonewton meter, and mdz just now we find out, that is 396.47. This is 396.47 is also kilonewton meter. So if you find out this value will be 750 divided by 2525.9, it is 0.296 plus 202.5 mz divided by mdz, 396.47. This value is coming 0.510. If I will add this to 0.296 plus 0.510, it is coming 0.806, which is less than 1. So it means that this our n upon nd plus mz upon mdz, which is 0.806, which is less than 1. So we can say that section is capable of, the given section, given ISHB 450, about 47.2 kg per meter, section is capable of taking 750 kilonewton load with eccentricity of 270 mm. ओके, अगर एसेंट्रिसिटी बढ़ेगा तो आपका मूवमेंट भी बढ़ेगा. दैट्स व्हाई दिस वी हैव मेंशन हियर eccentricity also. So this is the example. If the uniaxial bending example will come, then you have to solve the example like that. So this is all about the example, and we have completed this example. Okay. So once again I will repeat the step-by-step procedure so that you can once again understand properly. So this example is given. Check the adequacy of the section. ISHB 450. Section is given, so we don't need to assume the FCD and selection of section. This step is avoided. Axial compression of 750 kN with eccentricity of 270 mm about its major axis. Okay, the effective length of column is 3 meter. Consider only section is 10. Only uniaxial bending to this term in Y will not be considered. N upon NB or NZ upon NBZ less than equal to 1. This you have to check. This you have to check. Okay, for that step by step. First step, the section is given, factored load is given, eccentricity is given. Then section properties you can take from the steel table. This you can take from the steel table, all this level, steel table, or you can take from the IS 808 1989. These all properties are given. Then you will find out the forces. That load you know, you will calculate the moment. Moment is nothing but load into the eccentricity. Eccentricity on the major axis on the Z, MZ you can calculate. MZ you have calculated is 202.5 kilonewton meter. Then you have to classify the section because the section is given from the table number 2 of IS code and figures given in page number 19 of IS 800 2007. Then if section is plastic, it means that your beta B value equal to 1. This is the main reason for section classification. Design strength operation due to yielding, you have to find out that is ND. ND is nothing but AG FY from 190. AG you know, FY you know, you can find out. Then effective range you can find out the lambda. You know the lambda, you know the HF by TF value, you can find out the FCRB. The FCRB we have calculated. This is the FCRB we have calculated here. FCRB. Calculated FCRB using table 14 of IS 800. ओके, तो ये हम लोग ने इंटरपोलेशन से मालूम किया. आप इंपेरिकल इक्वेशन जो दी है आईएस कोड में वो भी यूज कर सकते हैं. एंड दैट इज गिवन इन पेज नंबर 54. दिस इक्वेशंस आर गिवन and this will data is PFBD. So here we can find out the FCRB value by using this equation. This equation is for FCRB value 1.1 pi square T upon LLT upon RY whole bracket square plus or under root of 1 plus 120 LLT by RY. You are there for the HF by TF whole square. So this we can find out from this. And all this pi E doing to power pi for steel. LLT LLT you can find out from the table. The table for the effective length of the beam column is given on table. Where it is given. Table number 15, I think so it is given. Table number 15. Table number 12. So which is it is given LLT table number 15. So this is table number 15. Effective length of simply separated LLT. So you can find out from here LLT and put all these values in the empirical equation. You can get that FCRB value. If you know the FCRB value, you have to find out alpha LT is 0.21 for rolled steel section, or if built up section is there, alpha LT value is 0.49. For rolled steel section is 0.21. Then you can find out the lambda LT, FY upon FCRB. Phi LT you can find out, alpha LT, lambda LT, you can find out phi LT. Put the phi LT value in XLT formula into XLT. And you can find out the query XLT into FY upon 1. This is another equation without using the table. Okay, so we are find out this by interpolation by using the table, or you can go by empirical equation. So you can find out this, and the FCRB. By knowing the FCRB, you can find out the FBD. Okay, FCRB 700 711 FCRB के लिए FPD कितना रहेगा वो मालूम करना है by interpolation. Then you know the FPD, or you can go the empirical equations given in the high score. There is find of the FPD. From the FPD, you know that the design stream bending MD is equal to beta B ZP FPD. Now put the value of beta B of ZP FPD. Beta B is equal to 1 for classic section. For complex section, ZP you can from the high score ZPZ, or which axis you are finding out, ZPZY or ZP as per the requirement, and then multiply with the FPD you calculated, you will get the MDZ value, and this is coming 396.47 kilometer meter. Then using the interpretation for the natural bending, the major axis only, because My is 0, then upon MD plus MZ upon MDZ. Put all these values you have calculated, and then you get the value 0.806, which is less than 1. It means that the given section uh, with the is capable of taking 750 kN load with eccentricity of 270 kN. So that is the example we have to solve. So this is all about the example on eccentric problem. Okay, and from tomorrow we are completed this. From tomorrow we will start the column basis. The column basis, you know that column basis uh, are nothing but like right now column basis. Column basis based on the loading. Based on loading or bending moment, there are three types of bases: slab base, flat base, simply the plate is below the column, gusseted base for medium load, and third one is the moment resisting base, moment resistance bases. So based on the loading on moment, we can design for this. This is for light load. This is for medium load with moment, medium load with light moment, and this is for if moment are large, large we go for this. So these are the different types of column bases, and we will see this inshallah on tomorrow lecture. So we will stop here. If you have any doubt with the example just now we have solved, you can ask with me, or otherwise we will stop here. तो सबको आई थिंक सो समझ में आ गया होगा कि कैसे हमको सॉल्व करना है ये एग्जांपल. ओके, तो अगर आपको नहीं समझा तो यू कैन आस्क इट मी, आई विल रिपीट आंसर. समझ में आ गया आपको? शैल वी स्टॉप हियर? Are you there or left class? Nobody is answering. Hello? Yes, sir. समझ में आ गया? Okay. So shall we stop here and we'll continue tomorrow with the part 2 of your unit number 3, that is column basis. So tomorrow please join on time 9 a.m. so that your lecture will not disturb and smoothly we will conduct the lecture. Thank you for joining today. So I will stop here. Thank you.